Welcome to another explainer. Today we are stepping into the director's chair. We're going to treat your Cambridge AS and A-level computer science exam like a blockbuster movie, and scene by scene, we are going to build your perfect top-tier answer. Cut the filler, keep the action. Right now, we're cracking the code on one of the most notoriously misunderstood topics in the entire 9618 syllabus. We're looking at topic 8.1, database concepts, and we are specifically zooming in on the limitations of the file-based approach. Now, to really understand the challenge here, I want you to imagine two students sitting down for this exact exam paper. Let's call them Alex and Sam. They open the paper and boom, there's a huge 12-mark question asking them to evaluate the limitations of a legacy file-based system for a massive hospital. Alex immediately panics and starts overloading the answer with every single raw computer science fact they can remember. Just a massive data dump, but absolutely zero analysis. Sam, on the other hand, starts rushing. Sam writes incredibly fast but completely misses the command word requirements. They describe a database instead of evaluating the file system. When the results come back, both of their papers are covered in red pen marks. If you've ever felt like Alex or Sam, studying the right material but somehow missing the mark on the actual exam, you are absolutely in the right place. We're going to transform those red marks into green check marks.
So why exactly is topic 8.1 such a massive hurdle? Why do smart students like Alex and Sam consistently lose marks here? Well, it really comes down to the pain points of multi-step evaluations and those elusive method marks. You see, you might have all the textbook definitions perfectly memorized, but when a question actually asks you to analyze the limitations of a file-based approach in a really complex scenario, like that hospital example, things completely fall apart. You can't just list facts. Today's explainer is a strategic masterclass built directly from the Cambridge Principal Examiner reports. We are bypassing all the generic textbook fluff. We are going straight to the source to understand exactly where candidates bleed crucial marks and how you can architect a strategy to avoid those exact same pitfalls.
Okay, let's dive right into this. Here is our structured battle plan for today. We're going to cover 1. The examiner's warning, 2. Core theoretical foundations, 3. The procedural framework, 4. Securing method marks, and 5. Critical analysis for top marks.
Let's start with Section 1, the examiner's warning.
Breaking down the principal examiner reports, 3 major traps emerge, and this is exactly where we see our students, Alex and Sam, stumbling. Before we continue, subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so the first trap. Using the wrong concept for the specific context. This happens when candidates memorize a pre-packaged solution but apply it to completely the wrong problem because they didn't decode the command word properly. The second massive trap is ignoring boundary conditions and edge cases. In the context of a file-based system, this means forgetting to test or mention what happens when data types clash across different departments, or when records are duplicated across flat files and suddenly the system reaches its limit. And the third trap, providing answers that are not specific to the context given in the question. This is where we need to introduce the PLL framework: point, evidence, explanation, link. Top students structure every answer this way. You make your point, you provide evidence from the file-based scenario, you explain the computer science theory, and you link it right back to the question. These 3 traps are where the vast majority of candidates lose marks they absolutely should have won.
To really emphasize that third point, consider this the ultimate examiner alert. Let's do a quick interactive check here. Look at this comparison on screen. Generic answers, like the ones Alex writes, just stating facts from the textbook, will always lose you marks. Context-specific answers, where you actively apply the PL framework to the scenario provided in the exam paper, are what secure the marks. Which one follows PL? It's the one that links every single point back to the given scenario. If the question is about that hospital's legacy file-based system, your answer better mention patients, doctors, and medical records. Saying files separate data is generic. Saying the hospital's legacy system separates the patient intake file from the pharmacy file, preventing doctors from seeing drug allergies, is context-specific. That is a blockbuster answer.
Moving on to Section 2, core theoretical foundations.
This is where the real transformation happens.
Let's take out our red pens and turn them into green check marks. Top-performing students don't just memorize isolated facts. The theoretical architecture of this topic rests on what we call conceptual integration. This means demonstrating precise definitions and, more importantly, understanding causal relationships. For example, why does data redundancy in a file-based system directly cause data inconsistency? Think about Alex again. Alex might write, file-based systems have data redundancy. No method marks awarded. But if we guide Alex to rewrite that using conceptual integration, it sounds like this. If a patient changes their address in the hospital's billing file, but not the separate medical file, this data redundancy means your file-based system is suddenly corrupted with inconsistent data. You see the difference? The examiner reports clearly state that candidates who draw these specific causal connections achieve significantly higher marks. It's about showing the exact chain reaction of why a file-based system fails.
And this brilliantly illustrates our computer science success blueprint. Look at the cognitive domains targeted here. Knowledge and understanding at the bottom, application in the middle, and analysis at the top. Cambridge prioritizes analytical depth over superficial breadth. They honestly don't just care if you can define what a file-based system is. They want to see if you can apply that knowledge to our hospital scenario and analyze its severe limitations compared to a relational database. Sam missed this completely by rushing and just defining terms. Your revision needs to reflect this hierarchy. You need to spend less time memorizing and way more time analyzing.
Let's move to Section 3, the procedural framework.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into the exact 5-step procedural framework. This is your visual story method for exam day. Step 1. Deconstruct the question. What is the command word really asking? Is it asking you to state, describe, or evaluate? Step 2. Extract the relevant data from the scenario. Who are the users? What are the files? Step 3. Select the appropriate analytical framework or concept to apply. Are we talking about redundancy, integrity, or security? Step 4. Execute with clear notation. This is non-negotiable. Step 5. Present your final answer using correct, precise terminology. Step 4 is particularly crucial, because if the examiner cannot follow your logic mapping, they literally cannot award you the marks. This framework is your script. Follow it, and you won't end up lost like Sam.
Section 4. Securing method marks.
Securing those method marks demands specific data interpretation skills. It's time for an interactive workshop. Challenge 1. Data scan. Imagine a complex data table on your screen right now, showing duplicated patient records across 5 different flat files in our hospital. You have 60 seconds. What's the core trend? The trend is that every time a doctor updates a file, 4 other files are left out of date. You need to be proficient at extracting these entities from a given scenario, mapping out those complex database relationships step by step, and drawing evidence-based conclusions on why a relational model might be superior to a flat file in that specific instance. That last point is key. You cannot just state a conclusion. You must show the evidence from the scenario that led you there.
Let's roll into Challenge 2, Find the Flaw. I'll read a sample paragraph. The file-based system is bad because it is old and databases are newer and faster. What's the flaw? Everything. It lacks specific computer science terminology and totally misses practical application. When you are asked to evaluate data integrity, normalize databases, draw an entity relationship diagram, or write SQL queries, remember that method marks are awarded for showing your logic at every single stage of the process. Challenge 3 is speed writing. In your head, structure a peel paragraph right now. Did you document your primary and foreign keys clearly? Did you evaluate the data integrity based on the specific anomalies that might occur? Show your working out always. You are the director. Show the examiner your storyboards.
Finally, Section 5, Critical Analysis for top marks.
This is where we build the ultimate complete computer science answering system. Evaluating a database system isn't just about saying it stores data. That's what Alex did. True critical analysis requires a mathematical and logical evaluation of trade-offs. You must evaluate based on data integrity. How secure is the data from corruption or update anomalies? Data independence. Can we change the software applications without breaking the underlying data structures, which is a massive failing of file-based systems? And data redundancy. Are we wasting storage and risking inconsistency by duplicating data across multiple flat files? Discussing the specific effect of these factors on system performance is the exact critical analysis examiners are absolutely desperate to see.
So how do you consistently demonstrate this evaluative thinking on paper? Top-scoring candidates share very specific traits. They consider alternative models.
They honestly acknowledge the limitations of a legacy file-based approach compared to a modern relational database. And crucially, they justify their recommendations for migrating systems with hard evidence from the text. Every single recommendation you make to the examiner about how a database should be structured must be fully justified by the data or the scenario provided. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Now, what's really fascinating about this slide is how it perfectly captures the ultimate goal of the Cambridge syllabus. Top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. If you just memorize past papers like Alex, you will fail when they throw a completely new, unfamiliar business context at you. But if you have that connected, conceptual understanding, you can analyze the database requirements of any random scenario the exam board dreams up, whether it's a hospital, a global logistics firm, or a local bakery. That is true mastery. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Which brings us to our final takeaway. It is time to stop relying on generic answers and textbook memorization. Take this context-specific, analytical approach, use our 5-step procedural framework, implement the PEL structure, and start hunting down those method marks. But before you close your books today, ask yourself a provocative question. If the legacy file-based approach is so deeply flawed, why do so many modern, multi-million-dollar businesses still secretly rely on it for some of their most critical, localized data? Think about the trade-offs there for your next revision session. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Catch you in the next explainer.